Hello friends, Satyendra here, and in this video, let's understand helical sweep in depth in Creo Parametric. So let's get started. So here I have several components which can be done by helical sweep. The first component is this spring. This is an extension spring, and if I change the free length of this spring, let's make it 150. The spring expands, and the spring expands, the pitch also changes. So this is one component. This is another spring, and this is also extension spring. Here the profile of the spring is different. It is not straight end to end. This is another spring. This is a compression spring. So if I change the free length, let's make it 50. The spring compress. This is one more spring. This is having multi-coiled ground end. Your spring actuated ball pin is having this kind of spring. So this is also done by helical sweep. Now the next component is a threaded bolt. So you can create V thread using helical sweep along with this smooth and clean exit. This is also part of helical sweep. Then you can use helical sweep to create a square thread. Just like this. Then you have this screw conveyor where you can use helical sweep to create this kind of profile. Now let's understand the helical sweep. So this spring is created using these details, and you have all the spring details here through which you will understand what is free length, what is body length, what is wire dia, what is outer dia, what is inner dia. So here once again we will create this spring using these details and go through each option inside the helical sweep. So let's create this spring once again, and for that go to new, part, solid, assign the name and say OK. So this is my new file. Now here let's understand the helical sweep first, and then we'll create this spring. And for this go to sweep. Inside this you have the helical sweep. Now once you activate the helical sweep, you get these options. Now to understand these options, first let's create a simple spring, and for that go to reference, define, select the front datum plane and say sketch. Normal, switch up the datum. First add a datum center line, then add a profile. So I'll add a straight profile just like this. Let's consider some value. So this I'll take as 25, this one I'll take as 50, and I'll say OK. I'll go to the section, I'll draw a circle. This I'll take as 5 and I'll say OK. So now you are getting a spring. Now let's start from here. So now it is in solid. So if you see the preview, you get the solid material. But once you change to surface, it gets converted into surface. So by this color coding you can easily understand this is a surface color. Now this is your pitch. So from here you can vary the pitch. This is your section sketch. So inside this you can go and modify the sections. This is the remove material. Using this you can create a helical cut. This is the thicken. So once you are inside the solid, you get this thicken option. Now this is flipping the material side. So if you flip it, you can see the material side. Now this is right-handed rule. So if this is selected, you get a right-handed spring, but you can change to left-handed if it is needed. Now when you are in surface mode, you get an option called capped end. So by default, the ends will be open. So if you use this capped end, the ends will be closed, but still it will be in surface. So let's make this section as 5 and pitch also 5 and say OK. Now I'll just create one extrude onto the top datum plane. I'll draw one circle somewhere here. This die I'll take as 25. I'll say OK. Now this height I'll consider as 100 and I'll say OK. Now I'll just move this feature above the helical sweep. I'll modify this feature. I'll go to remove material. This pitch I will make it 10. So now you see you are getting the use of remove material. I'll just delete this feature. I'll modify it and I'll uncheck remove material. So this area is done. Now let's understand these tabs. So if you go to reference, this tab is used to define the helix profile, or I can say to define the helix trajectory or the spring shape. So the reference tab is used to define the spring shape. Now this is pitch. So from here you can define either a constant pitch or a variable pitch. So now it is a constant pitch 10. Now if you go to this option tab, here also you have constant or variable, but this is not to define the constant or variable pitch. This is just to define the constant or variable section. So from here you can vary the wire dia of the spring, and from properties you can specify the feature name. So let's start with reference. Now from here you can add different type of profile. So now I have a straight profile. So I'll just delete this profile and I'll recreate one more profile. So this time my profile will be like this. So I have just added one random profile and I'll say OK. Now here I'll change the section. So this time I'm just considering it 2. I'll say OK. And the pitch also I'll take as 2. So now you can understand the profile. So this is similar to this spring. Now you can even go for a arc profile. So when you go for arc profile, your spring looks like this. So this was about helix trajectory. Now you have few more options inside the reference. This is flip. So if you use this flip, you can flip the start point of the helix profile. So you see. Now here this is helix axis. So if in case you have a predefined axis, then you can select that axis also. So axis got changed. Then this option, create helical trajectory curve. This option is available in higher version of Creo. So once you select it, you get this center trajectory. So this curve can be used in different ways. You can even use this curve to show as a center line. So this option is not available in lower version of Creo. Then you have this section orientation through the axis and normal to trajectory. So if I go to the right datum plane, you can understand from this. If you say normal to trajectory, then this section is normal to this helical trajectory, the way it is moving. But if you say through helix axis, then this section is normal to this axis. So by default, it will be in through helix axis. Now the next tab is pitch. So from here you can have a constant pitch or a variable pitch. So now it is in constant pitch. So if you add multiple pitches, you can vary the pitch. So now here you can clearly see that the starting pitch is 10 and it is gradually reducing to 5. Now let's add 2 more pitch. Make starting pitch 5, end pitch also 5 and these two 10. Now to understand it better, you make it 2 and then go to the pitch and here you make it 2, this also 2 and then this as a 5 and this also 5. So now if you see this, the start pitch is 2 and the end pitch is also 2, but in between you have the pitch 5. Now here there is a location type. So there are 3 types of locations. So you have a location by value, by reference and by ratio. So by value means you get a direct dimensional value here. So the total height is 50 and your first location is 25. So this is the first location, this is 25. Then the second location is this location, this is 37.5. So this location you can change. So let's make it 10 and this 40. So now your first location is here and this is 10 and your second location is here, this is 40. So now if you change this pitch as 10 and this also as 10, you can clearly understand. So from here till here this is varying from pitch 2 to 10 and from here till here it is constant pitch 10 and again from 10 to pitch 2. So this is how you can vary the pitch. So you have 2 more options inside this, by reference and by ratio. So if you go with by ratio, this trajectory length is considered as 1. So based on 0 to 1 you can apply the ratio. So if you need your first location at the point of 5, then you need to divide 5 by the total profile length. So 5 by 50 is 0.1. So you will apply 0.1 here and this also I will change to by ratio and then I will make it 0.9. So now your location got moved. So let's make it 0.3 and this 0.7. So now if you change it to value, you have 15 and you have 35. Now one more option you have, which is by reference. So by reference is very useful when you are applying the relation. So now here what I will do is I will place two sketch point. I will define the dimension and then I will go to equal. I will make this dimension equal to this dimension and this dimension I will take as 10. I will say OK. Now this time I will go to the pitch by reference and I will select this point. Here also by reference and I'll select this point. So now I am varying the pitch using this reference point. Now this reference dimension I can use in relation if I want. So this is very helpful to use in relation. Now you can remove the pitch easily, just like this. So once you have only one pitch, it will be a constant pitch. So this was the pitch. Now the next tab is the options. So inside the options, you have constant and variable, and this is directly applicable to your sketch section. So using these options, you can vary the section diameter. So now it is in constant, so you have the same section all around. But if you go for vary, you can vary the section. Just like this. So if you are in constant, it will be constant. If you are in variable, it will vary the pitch. So this option I have covered in a separate video in detail. You can watch that video to understand helical sweep with variable section. And that's it from the helical sweep. So these are the options inside the helical sweep. Now let's use these options to create this spring. So I'll just delete this spring and I'll start from the beginning. So to create this kind of spring which you are going to use in your assembly, we need to predefine some of the things before using helical sweep. So we need to predefine this end and this end before helical sweep. And for that, I'll directly go to the sketch, front datum plane, sketch, normal, switch off the datum. Now the next thing is add a center line somewhere here. Now this is the free length, so this is 100. Now draw the circle, tangent like this and tangent like this. Make these two circles equal. One more center line here and here. Go to delete segment and delete this segment and this segment. Now the OD is 30, so this dia will be 25, OD minus Y dia. So I am doing the center curve. Now I'll say OK. Now rename this feature as free length and rename this dimension as free length. So now if you go to tools switch dimensions, you can easily see that this dimension is free length. So from this dimension, we will control the length of the spring. Now we will go to the helical sweep. So go to the sweep, inside this, go for helical sweep, reference, define, and select the right datum plane. Now when you select the right datum plane, one thing you make sure that you should have top datum plane as a reference and orientation also top. So suppose you are getting this as front, then just click here and select your top, and from this drop down list you select top as orientation and then you go for sketch. Say normal, go for reference and select this point and this point as a reference. Then add a datum center line just like this, then a sketch center line to this reference and to this reference. So this gap will define the body length. Now draw the helix profile. So this time my profile is a straight line. So I will draw like this. I will choose this point as a start point. Now since OD is 30, this will be 25, OD minus y dia, and I will say OK. Now go for sketch section, draw the circle at your start point. Now this is 5, this is the y dia, I will say OK. Now my pitch is constant, which is 5, so I will leave as it is and I will say OK. Now the next thing is I need one connecting curve from here till here so that I can sweep this material, and for that I will use the datum curve. But to use the datum curve, I need a reference somewhere here. So for that, once again go to sketch, select this surface. Here also you make sure that your reference should be top and orientation also top. Now go to the line with construction mode and then you just draw a line like this. Then go to the datum point and place a mid datum point just like this and say OK. Your sketch is done. Same thing you done this side also. Select this surface, go for sketch, but always see your sketch setup. Your top should be top. Now once again draw the line in construction mode and then draw the datum point in the mid of this and say OK. Control D. So now if you switch on your datum point, you will see you have created a datum point here. Now you go to datum curve, select this point, press and hold Control key and select this point. So you are getting a straight curve. Now come to this yellow dot, right click and make it normal to this face. Similarly here you don't have any face, but you have a curve, so you can make it tangent to this curve. Flip the direction. You can even have one more option, curvature. So wherever that is applicable, you can go with that. So for me this is enough, I will say OK. Similarly, I will create one more curve this side. So I will go to datum, curve, I select this point, press and hold Control key and select this point. Make it tangent to this curve and make it normal to this face. Say OK. So now my connecting curve is done. Now I will go to sweep. I will select this sketch first, press and hold Shift key and select this curve. So now the entire curve will be considered as a single path. Now go to sketch section, draw the circle. Now the circle dia will be your wire dia, so this is 5 and say OK. Now you see material is not forming because the curve is having sharp bend. So if you go to surface, it will form. So it is saying that solid material is not possible because of the sudden bend. So I will say OK. So now to add the solid material, you can just go back to the curve, edit it, and here inside the options, you have option called tweak curve setting. Now first you go to the top datum plane, and then using tweak curve, you can smooth this curve. So I am doing this freehand. For precise value, you can go to the slider, and from here you can use it. So this is OK for me. I will say apply and I will say OK and OK. So now if you go to this sweep and change it to solid, it will easily form. Similarly, first you correct this curve. This time you go to the bottom view, go for options, tweak curve setting. Move this curve, make it smooth and say OK. Once again go to the sweep, select this sketch first, press and hold shift key and select this curve. Go to sketch section, draw the circle. Say OK and solid is forming easily. Say OK and your spring is done. Now if you change the free length of the spring, you see what happens. So I am making it 150. So this is happening, but this is not correct. So your spring length is changing, but instead of changing the pitch, it is adding some extra coil, which is not correct. So as you increase your free length, the body length is increasing, and based on the body length, it is adding additional coils. So to make this spring correct, you need to apply some relation, and the relation will be based on the free length and the body length. So now the free length is 100. So in that case, from here till here this is 25, and from here till here this is 25. So 25 plus 25, 50. So in that case, the body length becomes 50. 100 minus 25 minus 25. So if the body length is 50, your pitch is 5. So in case of 150, your body length becomes 100. So in that case, what should be the pitch? So this is the relation. So your body length is free length minus this and this. So let's write a relation, and for that go to tools, relation. Now here we are writing relation for pitch. So first select this helical sweep, go for profile and section and say done. Now here this is the pitch highlighted, so select it. So your pitch is D24. So D24 equals your body length, but you cannot use body length because there is no dimension for that. The body length is controlled with free length. So we need to add the body length in the form of free length. So I'll add one bracket here, and first I'll go for free length. So this is your free length, select it, minus 25 and 25. So doesn't matter how much your free length is, this dimension and this dimension will be constant, 25 and 25. So that put together it is 50. So I will say minus 50 and bracket close. So now this term is your body length, FL minus 50. Now when your body length is 50, your pitch is 5. So what is the ratio? 5 divided by 50, which is 0.1. So multiply it by 0.1. Your relation is successfully verified. Now you say OK. So now you try to change the free length. Make it 150. Now based on the body length, the pitch is varying. Let's make it 200. Still varying. Make it 100. And your spring is done. Now you can go to the view to change the appearance. You can select any appearance and apply to this part. Now once it is applied, if you change to shading with reflection, you get the realistic view of your spring. So this was the helical sweep in depth in Creo Parametric. Now I have one more video which is about variable section helical sweep, where inside the helical sweep your sketch section will vary. So watch that video to understand one more option inside the helical sweep. Now write your thoughts and comments about this video. So how do you see this video and what do you think about this video? So this was the helical sweep in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.